So let's talk a little bit about parallelograms. And to do that, I think we're going to use that GeoBoard app for the iPads that we have used before. Let's make sure we remember how to use it though. The first thing you do when you want to put a band on the app is you touch it and drag it up onto the board, right? So these 2 points here will represent the vertices of your figure, or the corners of your figure. If you want to move those, you touch or click on that corner and move it to another one. So here we go. When you want to put a new vertex in here, just grab it somewhere where it's not on a vertex and pull it to where you want it to be. Same thing here. There we go. So, you guys remember how to do that, all right? Use the different colors. So from there, one thing I want you to kind of think about and remember here is when we first were talking about rectangles, remember how we figured out how to find the area of figures like this that aren't pure rectangles? Anybody remember what we do?
You find the area of the big one and then the small one and add them?
Right, yes. If you take the area of this little piece right here, you can add another line there to kind of show. So what we have is 2 rectangles here, right? And we can find the area of that, add them together. So that will help us when we're looking at parallelograms. So remember, when you want to clear it, you hit the little circle arrow. It asks you if you want to clear it, and you hit OK. There we go. So, going back to this square here, or this rectangle, I should say, not square. All right. Somebody tell me what the area of this rectangle is? It's a little tougher since we're not marked how many units we have, but we have 1, 2, 3, 4, 5. Let's change it and make it 5. 1, 2, 3, 4, 5, 6. What's the area of that rectangle? Yes, Angela?
30.
30, that's right. Now here's my question. I'm going to take another rectangle, which has a base the same length. 1, 2, 3, 4, 5, 6. And you're going to have to take my word for this because you have not learned the concepts that you need to for it. But the length of this side here is 5, and the base is 6. How do we think that these two compare in area? Do you think they're the same, or do you think they're different? Anybody have any ideas? Angela?
They're different.
They're different. Can you tell me why you think they might be different?
Because the figure on the right looks smaller than the figure on the left.
Okay, that's reasonable, looking at it by eye and kind of matching them up. Well, I'm going to show you a way to try and find out exactly what it was. First, let me get rid of this guy here, and let's look at this one. So, what I propose to do is similar to when we broke it up into pieces with rectangles. We're going to take this and look at it this way. We have a line perpendicular to the base now. Just like when we do with triangles, we want to make sure that that line makes a square angle, otherwise if you want to call it that, to the base. But what we have here is a triangle. All right. Now, we don't know, not sure how to find the area of triangles yet, right? We'll talk about that later. But what we can do is we can take this triangle and move it to the other side, just like that. Can you see how this triangle is the same as this triangle? Okay, so since we moved that triangle, we can take this part of that away. And now what shape do we have?
Rectangle.
A rectangle, that's right. Now, can somebody tell me the area of this rectangle? Remember, our base was 6. And now our height is 4. So the area of this rectangle.
Is it 24?
Yes, 24. So, do you remember what the area of the last rectangle that was 5 high was 30? So this is smaller. You were right, based on inspection. Nice work. So, using that, we can kind of figure out, maybe figure out a formula to solve it. Let's take and put this back the way it was. Now, remember, what did we use as the base when we found the area of that rectangle? It's the same base as we have right here, 6. So, in a parallelogram, we call this one the base. And now, when we move that over, what was our height of that rectangle?
The height of the triangle.
Same as the height of the triangle there, that 4 right there. So, if we need to find the area of a parallelogram, we do it like a rectangle, but you need to make sure your height is a perpendicular line to that base. That's all that's to it. Let's try a couple of examples here. All right, why don't you take a look at this one here and see if we can figure out what the area of that parallelogram is. Anybody figured it out yet? First, let's look at it. Can somebody tell me the length of the base?
6.
Yes, 6. 1, 2, 3, 4, 5, 6. All right. Now, the part we just learned, what would the height of this parallelogram be? Yes, Jenna again. Brittany again.
5.
5, yeah. 1, 2, 3, 4, 5. Because that's where it's perpendicular to the base here. Roll. Let's see if I can do one that doesn't have a base of 6 once, just to change it up. Now we're getting a little trickier, but I think you can still get it. Think about that one for a minute. In the meantime, I'm going to make another one for you guys to think about. All right, what do we have for a base for this one here? Angela?
2.
2, yes. 1, 2, right there. Now, how about the height for this one? Jenna, or I keep calling everybody Jenna. Angela again.
4.
4, let's take a look at that. If we're looking at it like this, we want it to be perpendicular to the base. So I think a good thing to do would be to extend this base out so we know where it's perpendicular. underneath this line here. To go right down to there. I'm gonna do, what do you think about that idea now?
6.
6, yes, I think that's better. 1, 2, 3, 4, 5, 6. So if our base is 2 and our height is 6, what do we have for an area for that one? 12, yes.